Welcome to the webinar. Let's start. I hope you can see the screen. Okay, so let's start. Thanks for joining in. My name is Shashank. I'm a senior mechanical engineer here at DECOS. Today I'm going to talk about FEM method, that is finite element method, and how it is used to solve various product failure and heating issues which we face in our day-to-day product design and development cycle. Okay, so let's talk for the agenda about the agenda. The agenda of the day will be strength and solids, finite element method in analysis and its applications. But the core agenda of this webinar focuses on why organizations need FEA. We'll discuss on how FEA can be used to digitalize and provide specific examples of its applications in the medical domain. This webinar will also provide you with a basic understanding of finite element analysis and how it can benefit your organization. We'll also discuss about the basics of stress and effect of elevated temperatures on strength of materials, what is heat, modes of heat transfer, about FE and why we need it. I'll solve you or showcase a classic example of three different materials sandwiched between stainless steel 316 plates at elevated temperatures. What is the deformation under a particular set of loads? And if when the temperatures are not increased, then what is the deformation? Okay, we'll compare that. And towards the end, I'll also share details about what services we offer in this area. So before we go to the further into the webinar, just wanted to know how many of you are already using FEA technique in your day-to-day work. So I'll open the poll for you. You can go to the webinar chat and there you can give your poll, your answer. I hope you can see the poll is live now. You can give your answers over there. Okay, great. We have 50-50. So we have people who wants to learn more. We have people who already know the topic, but they want to see further into it. They want to understand it better. Great to know that. Okay, let's move into the webinar. So first, let's understand why we need to know about solids and their behaviors under different loading conditions. To understand the strength of a solid, we must understand that each solid behaves differently under different set of loads. If there are two parallel rods on both sides of a cube, one is on the top side, another is on the negative direction, then the body will be subjected to shear loading. Similarly, in case of forces perpendicular to the cross sectional area of a round bar or a square bar, then the specimen will be subjected to tensile loading. Other way around, it will be compressive, right? Similarly, there can be bending stresses, there can be other stresses, there can be a combination of stresses, right? So each solid behaves differently under different loading condition, right? Now, let's define what is strength of a solid. Okay, so strength is defined as the capacity of a structure to resist loads, right? In other words, a component which can take more loads and without failure or without a significant deformation, if it is still fulfills its application for which it is designed, then it is said to have higher strength, right? So that's how the strength is defined. It's the capacity of the structure to resist loads. Fine. Now, let's discuss about a case where a low carbon steel rod or a mild steel rod is subjected to tensile forces along the longitudinal direction of a rod. Okay, the behavior of the rod under such loading conditions is depicted over here in the stress strain curve, right? As shown on the right of your slide, and my pointer is highlighting that. Okay, so I'll not take you through point by point how exactly the rod fails. So, but I'll try to define or I'll try to touch base upon certain points which are important to know and are substantial to understand, right? Now, as we try to deform the rod, that is, introduce a strain in the body, which is plotted on the independent axis X, there are, because of the external forces, the body try to resist these deformations, Okay. Now these average resisting forces per unit area is called stress, plotted on the y direction, y axis. Okay. Now the stress can be nominal stress or true stress. Nominal stresses is the ratio of forces by the original cross sectional area of the rod, while true stresses are the forces subjected, that is the external forces, and the cross sectional, and the ratio underneath in the denominator is the cross sectional area, but it is instantaneous cross sectional area, because this cross sectional area keeps on decreasing when the length increases, because the rod is subjected to tensile forces. Okay. Now let's discuss points like yield stress, strain hardening from the graph. Okay. So after point B, there is a significant plastic deformation in the body, right? Now, but there is no significant change over here in the stress. Okay. So because of the substantial elongation in the rod as compared to increase in the tensile forces, this particular phenomenon is called yielding or perfect plasticity. So we have elastic deformation and we have plastic deformation. The elastic deformations where the body spring back to its original condition, while in case of plastic deformation, the body will not spring back, but the deformation stays within the body, right? Okay. Let's move to strain hardening. So, after a substantial plastic deformation from point B to point C, the body starts showing great resistance towards the external forces, right? Now, when the body shows great resistance towards the external forces, that is, there is significant increase in the stress, right? Now, this increase in stress is because of the change in the crystalline structure post plastic deformation of within the rod. So, because of the change in the crystalline structure, the resisting forces increases substantially. This phenomenon is called strain hardening. Now, this is important point, and it is significantly used in different manufacturing processes for hardening. Okay, so now as we have now learned what is strength, how a material under pure tensile loading behaves, and how it can be plotted. Right. Now, I would like to mention or substantiate on one point over here, that the failure of the material which we have discussed is under pure tensile loading. The body will behave completely different in case the set of loading is different. If it is not pure tensile loading, or if it is a combination of two, then the body may not fail in the similar fashion. Okay. The failure can be different. Let's move. Now, once we have covered the basics, let's move to finite element method, right? And how it helps us to assess the strength of a product, which in turn helps us to predict the failure. Okay. So, why actually we need finite element method? So, in the real world scenario, we usually come across products or components under various types of loading conditions, right? Now, these loading conditions are multiple stresses at the same time. Okay. Now, this issue is aggravated by the complex geometries, the non-linear behavior of the materials, and other reasons. So, there the non-linearity comes into picture. So, the example which we were already, when when the rod was subjected to pure tensile stress, it's easy to solve by conventional methods or by hand calculations. But once the complex geometry comes into place, the diverse materials comes into place, or the various loading conditions comes into place, then the conventional methods have their own limitations. Okay, that's why we need finite element method. Now, finite element methods helps to imitate real world scenarios in a virtual world. It makes use of numerical methods to approximate solutions to real world problems. Okay. Most of the physical world problems can be converted to partial differential equations. For example, a fluid flows from one point to the other point because of change in pressure, or because of the difference in pressure. Two bodies exchange heat among themselves because of the difference in temperatures. Similarly, in electrical terms, if we discuss, current flows from one point to other just because of the difference in voltage between the 2 points. Okay, hence different physical phenomena are depicted by using differential equations. Now, these differential equations can be utilized further in finite element methods and solve them. They are converted to system of linear equations. So the numerical methods which are used in finite element method are derived from Newton's law of motion, conservation of mass and energy, and laws of thermodynamics. Okay. Now, as in a real world scenario, what we do is, if we have a real big goal or a target, what we do, we divide it into few smaller targets. Okay. Then we try to hit those small targets one by one, right? Similarly, in FEA, a large product is divided into finite number of elements. Each element is connected to each other and are governed by a numerical or a mathematical equation. These equations are analyzed, and solution of a single element is interpolated over the entire domain. Now this domain can be surface or volume, right? Depending upon if you're doing a static structural analysis or you're doing a fluid analysis. So we are not discussing the numerical methods here in detailed fashion, but still, if you want to read about them, I would suggest you can read about Rayleigh-Ritz method and Glarkin approach, which are the two most commonly used approaches. Okay, let's take a deeper dive into finite element analysis and which makes use of finite element method. The flow on the chart over here shows you the different steps which are followed while doing a finite element analysis. The first step is geometry cleanup. Now, in the geometry cleanup, what we do is we in CAD model of the assembly or the product which you want to analyze is created, or we can is created. Then after that, because we need to divide it into finite or small elements, we do a cleanup of the geometry. How we do a cleanup? Consider what we do is, if the body is having multiple burrs, edges, sharp corners, or there are multiple components which are not needed, or by our engineering aptitude we are able to make a clear guess that okay, this particular component will not affect my final outcome. Okay, so we can discard them. The idea is to reduce the complexity of the geometry so that the computation time is reduced, and the results which we get, we are easy to finalize that what particular component is affecting my final results. Okay, if you have multiple components, then it becomes difficult to uh, analyze in the post processing that what exactly is the reason of this particular output. Okay, now, after cleaning up the geometry, you import the 3D CAD geometry into a FEA package. Now, FEA package can be ANSYS, Nastra, Nabacus, SolidWorks, etc. Right? Now, after you import it into FEA package, you start defining material properties. Now, we define the material along with the material properties. Now, these material properties depends on what particular type of analysis you're doing. If it is static structural, you need to define modulus of elasticity, density, yield strength, and etc. Okay, so on and so forth for other analysis. Now, let's come to meshing, which is the most critical part of a finite element analysis. Now, meshing is the process of dividing the geometry into finite elements. Okay, and meshing is also defined as a process of dividing infinite number of points into finite number of elements and nodes. We'll discuss about elements and nodes in my subsequent slide. We'll discuss on them what exactly, what are elements, what are nodes, and what are the type of elements. Okay, now meshing is one of the most important steps to achieve accurate results. It is also called discretization. That's what we do. We create discrete elements of a complete geometry or complete model. Okay. Now, after the model is divided into finite number of elements, we need to define real world conditions in virtual world. These conditions are called boundary conditions. For example, defining the contact between the two bodies, defining gravity, defining force, temperature, etc., of what exactly is there in the physical world, in the virtual world. So these are the boundary conditions, and whatever boundary conditions you're going to put, those will decide that what will be your outcome. Okay. Now, once you define the all these things, 5 steps, you come to solver. The FEA solver makes use of basic equations and formulas to solve the problem, like bending equation, torque equation, Navier-Stokes equation, and other mathematical relations based on the problem. Once you have the completed solution, these solutions are plotted on over the entire geometry or the product. Like if it is thermal analysis, then the temperature will be plotted over the entire geometry or whatever geometry you want to analyze. Okay, so this process is called post processing, and this involves analyzing the results by a FEA solver to take decisions. So once you in the post processing itself, you also realize the or you also analyze the results. Okay, let's move to elements and nodes. So elements are defined as the building blocks of meshing. Okay, Nodes are the junctions which are created by the connect of between two elements, right? Now these nodes helps us to define the degrees of freedom, okay, at a particular point. Now there can be three types of elements based on geometry and plane. It can be 1D element, it can be 2D element, it can be 3D element. If it is a plain 2D element, if it is a complete solid geometry, then it is 3D element, and most of the times we deal with 3D elements. Okay. Now, 1D element can be truss element or beam element. Beam and truss element are used for modeling the cylinder structures like beams, columns, and cables. Now, the difference between the truss and beam element is beams element can are able to sustain the bending moments or handle the bending moments, while truss elements cannot. Okay. Fine. Now, let's discuss about the triangles or triangular elements or tetrahedron elements. If it is 2D triangle, if it is 3D tetrahedron or tet mesh, which is commonly used word. Similarly, quadrilaterals and hexahedron. Okay. Now, triangular elements are simple and versatile for complex geometries. Okay. And they are often used for fluids and irregular surfaces or solids. But in case of quadrilateral and hexahedron, they are used for regular geometries like cubes, cuboids, and others. Okay, so hence the triangles or the tetrahedrons are used for irregular or complex geometries, while quadrilateral or the hexahedron elements are used for regular geometries. While the accuracy will be more in case of quad or hex mesh, because you create more number of points to solve the problem. Okay, let's move to next slide. Now we have already discussed what is finite element analysis, how it is used, or finite element method, how it is used in finite element analysis, and what is the basic structure of the process which is followed in the finite element analysis. Now, many a times as a CAE engineer, people ask me this question: how accurate are these results or mechanical simulations which you perform? Okay, so in order to answer that question, I'll show you a video so that you're able to make out how exact the results which come out of FEA are, or how reliable they are based on their accuracy. Okay, so now you can make out how accurate these results can be, which are performed with the correct boundary condition, correct meshing, and correct post processing. Okay, let's move to the next slide. Now, when we have already discussed the process and their accuracy, let's discuss why we need FEA or finite element analysis. Now, the first point is reduced need of physical prototypes. Now, with the initial review of product in virtual environment, the number of prototypes reduces, right? Now, as we predict the failures and find out the most optimized design for a prototyping, instead of creating multiple prototypes, so we are able to reduce the number of prototypes, right? Now, let me clarify or put up this point that the FEA does not eliminate the prototyping process. It just reduces the number of prototypes, right? Okay. Now, early identification and correlation of design flaws. So the more you push the FEA further up into the product design and development cycle, the better it is. This helps you to make quick decisions, and the designer can make more informed decisions while assessing multiple design options, right? Now, next point is the material optimization. Now, as we know that with the advent of material technology and the advanced materials which are coming in for each application, it is mandatory to test every element or every material before the designer finalize or circles down to one, right? Now, also material decision on materials is based on manufacturing process which are going to take, and mostly the cost which plays a substantial role while comparing the different materials. So FEA helps you to put in different materials, analyze the outputs, and understand how a particular material fulfills your need. Next one is the enhanced product quality and reliability. Now, as simulation facilitates shift change in design and materials or manufacturing process, it becomes easy to assess the quality and reliability of the product, and it takes measures to enhance quality and reliability. Faster time to market, yes, because the prototyping or the number of prototypes reduces, so you are able to reduce the product design and development cycle overall, so hence you can hit the market early, right? Okay. Now, one more aspect which I want to touch base over here is digitalization using FEA. How the FEA helps you to instigate digitalization within your organization by digital prototyping, by predictive maintenance, by virtual testing, by life cycle analysis, and by creating a complete virtual model in a system which replicates your physical environment completely, the maintenance, the life cycle, the behavior of a particular product within the virtual world. Now this particular phenomenon is called digital twin. So you can analyze or you can understand to what extent FEA can help the product design and development cycle. Let's discuss on the application of FEA in medical domain. So FEA helps you in medical domain. It can help you in implant design. It can help you for doing a surgical simulation for a particular type of patient to customize the entire process for each patient, to understand how the tissue or the tissues in a human body behaves or responds to a particular type of mechanical stimuli, right? And nowadays each one of us have a wearable health device in order to monitor our BP, monitor our sleep cycle, monitor and different things, right? So each wearable device, when it becomes smaller and smaller, it creates electrothermal issues. So FEA can help you to mitigate those electrothermal issues. Now, let's come to the case study. That is the last part of our webinar where we are going to discuss how FEA or helps us to understand the elevated temperatures, how they affect the strength of a particular material. Okay. Now, I'll discuss the setup over here. So this is a CAD model of a setup where three rods, brass, nickel, and aluminum, are sandwiched between SS316 100 by 100 plates. Okay, the bottom plate is fixed while the top plate is subjected to 500 Newton load. So let's solve for it in FEA package for deformation. I have solved it in SolidWorks. So the maximum deformation which the body undergoes is 0.002 which is almost negligible. This is the displacement plot. Okay, now let's bring in the condition of temperature where the top plate is subjected to 150 degrees Celsius and the bottom plate is subjected to 500 degrees Celsius temperature, constant temperature with time. Okay, and the temperature plot or the temperature distribution over the entire geometry can be analyzed by the thermal analysis, which I am highlighting as of now. Okay, so this is the temperature distribution within the geometry. Now, let's see if we import the temperature difference with 500 Newton load, the deformation increases to zero point 0.4 right? There is a significant increase from 0.002 to zero point 0.4 So this shows you how elevated temperature can particularly affect the strength of a material, and at a very small load of 500, even at the 500 Newton. And this is also because of the change in thermal expansion property of all the three materials, that is brass, nickel and aluminium. Okay, so I hope I am able to make you understand that how temperature brings in the change in strength of a particular metal for a particular application. Okay. So now let's discuss about the services which we offer in this area. So Decos is a strong player in software service industry for last 20 years. Okay. We started venturing into engineering services in early 2020 and delivered significant projects for various clients in the field of static, structural, and thermal analysis. Okay, so the list of different services which we offer in this area are enlisted on the left of the slide. First one is the static. First one is the static structural analysis. So, static structural analysis is done to generate stress plots, strain plots to understand the deformation at a particular type of loading when the product is in operation or when it is not in operation. In both the cases, we can identify weak spots, we can identify the stress concentration points, which will let us help us to understand where the failure will occur, right? Next one is the product optimization. Now this product optimization is to understand that with the same resources how much we can achieve, or even by reducing the resources can we achieve more with the same, right? So that is product optimization. This can be design optimization, this can be material optimization, or other processes. Now nonlinear analysis is introduced in a system due to complex geometries, materials, or due to the contact between different bodies. Okay, in most of the day-to-day work or the product which we work, non-linearity is very evident and it always comes into picture. So we are capable of delivering even those analysis for you as well. Now, the thermal analysis, we try to understand if there is an overheating, or there is a sudden heating within the body, or because of certain bodies, we want to understand that how much it is going to increase the temperature. Like similarly, what we have discussed in the case study. Okay, so those will come into the thermal analysis service. Impact and drop test. Now, impact and drop test is can be within when the product or assembly is working during the operation, it can undergo an impact is nothing but a force which is time dependent, right? Now, and or if it in case of, like we have taken example of a mobile phone, on the right of your screen you can see, if it drops, then what will be the damage, what because of the particular impact, or the video which I had shown where there was a car collision. Those tests are all comes into impact analysis. Now, vibration and modal analysis, here we try to identify the effect of operational frequency on a product or a component. Or we can also analyze the unwanted noise that can be real issue in case of dynamic components. So if you have a motor or an engine or any moving component within your product, you have to understand that in case of any random vibration, so what exactly is causing the random vibration within the assembly. Preliminary flow analysis, where you want to understand how the solid behaves, interacts with a liquid, or if there is a mixing of liquid, how exactly the mixing happens. All those analyses will come under preliminary flow analysis, that is CFD analysis. So these are the list of services which we offer in the under the engineering services domain. Okay, so that's all for the day, which I had to share today. I hope I was able to make you understand and touch base upon the finite element method and finite element analysis, why it is important for your organization and why you should use it, how it reduces the product development cycle and you can reach the market early, or you can have a better edge over your competitors. So, we would be happy to help you with any of your product design development or prototyping, optimization and troubleshooting issues. We have cutting edge technologies and tools which you make use of to provide solutions to you. You can make note of the email IDs which are available over on the slide as if now. Also, there will be a recorded version of this webinar which will be available on our website within a week's time from now. You can also send us an email and we'll be happy to answer your questions. Okay, so that's all I had for the day. In case you have any questions, you can drop us a mail and we'll be happy to answer those mails. Do interact with us even if you don't have questions. You can post any query or anything else if you want to discuss with us. Okay, so that's all. Enjoy the day. Bye bye.